Hi, my name is Dhru. I'm a second-year student at Maths and Stats at the University of Plymouth, and I'm going to show you how to prove sine squared plus cos squared equals 1, one of our favourite trigonometric identities, for some angle theta. Cos squared is 1. Now, not many of us will be used to dealing with sine and cosine as functions, so we have to think about ways in which we are used to dealing with them. So, let's draw a right-angled triangle. Here's my right angle, and I'm going to call this angle theta. Yep. Now, for now, let's not worry about sine and cosine. Let's try and use Pythagoras' theorem, or at least let's try and label this triangle so that we can use Pythagoras' theorem. So I'll call this side A, this side B, and this side C. And as we know from Pythagoras' theorem, a squared plus b squared equals c squared. Yep, the lengths of the sides. So I'm going to rearrange Pythagoras' theorem so it looks a bit more like what we want over c squared. All I've done is divide by c squared, and I'm going to take that index outside of a bracket now. A over c all squared plus b over c all squared is also 1. Right, so that looks a lot like that. That's great. But how do we know that these are going to be a bit like these? Well, let's use definitions of sine and cosine that we've all seen at GCSE as well, using the famous SOHCAHTOA, which I'm sure a lot of people will remember. So we have sine is the opposite over the hypotenuse. These are all lengths. Sine of theta. And the cosine is the adjacent over the hypotenuse. Yep. So now we have to identify on here our hypotenuse, which is C, our adjacent angle, which is A, and our opposite angle, side, which is B. So now we can write this as the opposite, B, over the hypotenuse, C. And we can write cosine as the adjacent, A, over the hypotenuse, C. Right, okay, well we've got A over C all squared and B over C all squared, so we can just plug that in. Sine squared theta, which means to say sine of theta all squared, it's the same thing, plus cosine squared theta is 1. And we use this little box to say we've ended the proof. And hopefully now you'll understand where this very important trigonometric identity comes from. A lot of A-level students will be using this all of the time. Thanks for watching.